Hello everyone and welcome back to another statistics video. So in this video we are going to talk about continuous probability distributions or continuous random variables. And we're going to see two different ones in this section. We're going to see the uniform distribution and then we're going to see the normal distribution. And when we talk about a uniform distribution, we're talking about distributions that are um, really going to be the same height all the way across. So they're going to look kind of like a rectangle. And the area of a rectangle is length times width. And then when we talk about the probabilities associated with things, then we're talking about the area underneath the curve. So let's say I'm looking at the probability I'm between A and B. Then our probability distribution could be represented by the picture shaded here between A and B. And to find that, I would find the area of that rectangular region. So let's look at some properties of the uniform distribution. The first property is that the total area under the curve must be equal to 1. So if we were going back to this probability distribution, total area would be from here starting at 0 to C, and that would have to be equal to 1. The second property is that every point that's on the curve must be above the x-axis. So in other words, the vertical height has to be greater than or equal to 0. So let's look at some examples of continuous probability distributions. Now, one thing that is different from a discrete random variable here is that if I want to find the probability that x is greater than a, that's actually going to be equal to the probability that x is greater than or equal to a. Now we're equating things to area under the curve. So if you think about what's going on under the curve, I'll call this point, we'll call it A. So here's my height, which would be 1 over A, because A times 1 over A for that area, that rectangle, would be equal to 1. And if I'm finding the probability that I'm greater than or equal to some value, actually, you know what? I'm going to change my mind here. I'm going to call this C. And then I'll call this A. So we're talking about this area here. It doesn't really matter whether I include that line there at night because that line there or not, because that line is so thin that just by itself, it's not really going to affect that area under the curve. And now we're thinking about things in terms of areas. So let's look at a few examples of continuous uniform distributions. So here we've got this continuous distribution. They're telling us the area is equal to 1. So from here to here is 5. It would make sense from here to here that would have to be 0.2. Even if we didn't know what that was, we could figure it out because we know the area has to be equal to the length times the width because it's a rectangle, and it has to be equal to 1. So if I know that the length of this is 5, I could figure out the width just by solving a little math equation. So it would be equal to 1 over 5, which is the same thing as 0.2. But this one was nice, and it gave us that 0.2 value for us. So let's look at just a couple of examples. 5's asking us the probability that we are greater than 3 minutes, which means that we're having to wait longer than 3 minutes. So greater than 3 minutes would look like that. So I'm trying to find the area of this piece here. So area is the length times width. My length is 2 units long. My width is 0.2, so my area is going to be 0.4. Let's do another one. Let's look at 6. 6 is looking at the probability that we are waiting less than 4 minutes. So less than 4 would be this area. So we just need the length and the width. The length is 4, and the width is 0.2. So my probability is 0.8, which says that we have an 80% chance of waiting less than 4 minutes. 7, probability that we're waiting between 2 and 3. So 2 and 3 would be this area in here. I could write that mathematically as 2 is less than x is less than 3. So that has a width of 1. And we know the height is 0.2. And 1 times 0.2 is 0.2. And then 8. Finding the probability that we're between 2.5 and 4.5. And again, it's all about that area under the curve. So 2.5 to 4.5. So that width is 2 units wide, and the height is 0.2. So that's going to give us a 0.4 for that area. So that's how we would deal with a continuous uniform distribution.